Good morning. Actually, my Chinese is not very good, so I will switch to English.
咏春，你给我非常好的介绍，
I'd like to thank the moderator for your warm introduction.
And I think Daniel actually stole a lot of my thunder because I think we're all very excited about Internet of Things. Internet of Things has been a big hype since, I would say, 2014. You know, the consulting agencies have told us, and again, the possibilities, the economic value of Internet of Things. And so I'm sure IoT is not a surprise for you. What's even more impressive about IoT is the application of IoT. And Daniel's done an excellent job telling us how IoT has applied to Industrial 4.0. And so I'll tell you a little bit about that too. And also from an IBM perspective, how we think about IoT and what our strategy is in what we were going to do with the possibilities of IoT, the data of IoT, and how we can help companies and enterprises transform their business with IoT. So I think I'll start off with why is it here? I'm sure you guys all know it's here, but I want to set the context, I want to set the stage first. A little bit of a history lesson on IBM's venture into IoT. So really, we started IoT back in 2008. We did an initiative called Smarter Planet. And what Smarter Planet does is it focuses on three things: intelligence, interconnectivity, and instrumentation. What that means is you take your systems out there, you instrument them with sensors, with chips, you start to connect them, and then you're going to start to get intelligence out of it. But back then, we didn't know to call it IoT. That wasn't the terminology. Our ambition was to create a smarter planet. So a lot of the initiatives around interconnectivity, instrumentation, and intelligence was actually done with municipals and with government, because we're doing large-scale transformation. But what we realized was that kind of transformation in 2008 was difficult. It cost a lot of money, mostly because the 5 driving stages that you see here didn't exist back in 2008. Well, it existed, but it was very, very expensive to implement. But what do we see now? But what we see now is actually there are 5 driving technology movements that's allowing us to get to IoT. And so very basically, if you were to see the slide behind me, is that embedded sensors are everywhere, and embedded sensors are cheap. I think an excellent question that Yongchun had brought up was, you know, for some of the factories in China that's still at Industry 2.0, how do we get started? It's actually not that hard. In fact, it's very easy, because think about how you can leapfrog the competition. Because you don't have this infrastructure that's been set up from stage to stage, you can actually start to instrument your devices immediately, because sensors are cheap nowadays. Connectivity is also pervasive. You know, I think we all see it in our everyday lives, the way that we use mobile phones, right? We get internet almost everywhere. Actually, I think one of our executives quoted this excellent statistic. She said to us, "Johnny and the rest of the IoT team, I expect that you guys will be always online, always working." And we said, "Why?" And she said to us, "Well, the only place that really doesn't have internet is Myanmar. So unless you're in Myanmar, I think you're always online. And so you can always respond to my question." So that's my point. Connectivity is pervasive. It's everywhere, and it's going to be able to help us. Already. The third one, I think Daniel's already alluded to. What is cloud, right? Cloud computing is actually extremely acceptable nowadays. Cloud computing is done by most of the corporation in various types, right? There's the public cloud, there's the private cloud, there are hybrid clouds. So all of these are actually extremely apparent. And cloud computing has become secure enough, easy enough to maintain, and easy enough to get started for it to be applicable. I think product lifecycle management is a really interesting one. When people think about product lifecycle management back in the day, it was actually still very siloed, right? You have a design phase, you have a manufacture phase, you have an operation phase, you have a service phase. They're separated into pieces. What IoT allows us to do is be able to connect all the dots. Now, from any stage of the game, you would have information from the other phases. So design would be more seamlessly connected to manufacturing, and manufacturing would be able to tell service calls and be able to diagnose and debug things back earlier in the design phase. So it's very interesting how all of these pieces start to connect together. And what we're most excited about is the analytics. In fact, we're going to take it a step further. From an IBM perspective, analytics is not enough. Your analytics now need to be cognitive. What does cognitive mean? Cognitive means thinking. It's a thinking process that humans use. And what makes that different from analytics? Analytics is algorithms. You start to see patterns and trends, you start to apply the same patterns and trends, and you start to get insights out of it. But what if you could take these analytics, the patterns, the trends, the logs, your history, combine it with other sources of data, combine it with reference to other types of events? Now you start to become thinking. So the application of analytics combined with other data sources, combined with machine learning, combined with iterative learning will really get you to the next stage. And that's absolutely critical for IoT, because IoT is going to be such a large data tsunami that conventional computing is not going to be enough. You have to take it to cognitive. You have to be smart about how you analyze. So our strategy, looking at these 5 technology driving factors, are these 3 on the right. So what we are thinking when we talk to our clients about IoT is that we think there are 3 major value drivers. Go back one, please. Thank you. There are 3 value drivers that we think we support in our enterprise and our companies. So first off is improving operations and lowering costs. This is a very easy one to digest. Everyone wants to save money. IoT can help you save money because it'll allow you to automate things. This is also the type of value that typically has the fastest return. And when we talk to our enterprise customer and we say, let's start to take a look at the data that's in your manufacturing plant. Let's talk about how the data that you see there can improve your operations and your processes. That's the easiest one to digest. But most people are actually really excited about the second one, which is creating new revenue, new products, and new business models. And what we find with our clients is that we usually hit the first one first, obviously. So once we save the money from lowering costs using IoT, we then apply that money to developing new businesses and driving new business model change. And then obviously the last one around driving engagement. What IoT has given a lot of enterprise customers is a very unique advantage about touching the end user. So I'll give you an example. We have a very big partner customer, Whirlpool, that manufactures washing machines and dishwashers and things like that. What's really surprising when we talk to them was they actually do not know how their product is being used out in the field, because they build it, they ship it, they distribute it, and it's bought by an end consumer. But the end consumer never talks to Whirlpool. They don't say, oh, this is how I'm going to open my washing machine, and this is how I'm going to put in the detergent. They don't have any visibility to that. They have a very limited time where they start to where they ask you for a warranty card, and that's the minimal touch that they get. But IoT allows them to actually see into their end users. Now, when you ship a washing machine and you start to use it, they can detect how you're using it, how hard you're pushing buttons, which types of settings you're using, so they know to improve on that in their next generation of products to make your life better. So those are our top 3 values of IoT. So if we move on to the next page, I'll cover this one really, really quickly. Everybody has seen a lot of numbers, and I think these numbers are from McKinsey. A lot of our other consulting firms can give you other numbers around IoT. But the point of it, the main idea, I guess, is that by 2020, there's going to be a lot of devices. And the devices mean that you're going to start to be able to see value on the data that's coming off of these devices. The potential economic impact is $11.1 trillion for IoT. And then 4.6 of that is something around smart manufacturing, Industry 4.0. The other statistics I'll mention here that's not covered is a lot of people have a context of what IoT is. A lot of people think about IoT and they think about smartwatches, they think about very consumer applications. That's actually not true. Actually, McKinsey told us that over 70% of value-driven use cases for IoT is actually B2B or B2B2C. So it's mostly driven in enterprise value. It is actually not consumer. Only 30% is consumer value. So think about that as you apply IoT forward. I'll move forward another slide. Thank you. So why do we keep talking about IoT? The application of IoT, specifically in this work stream, is around manufacturing. I think Daniel's done an excellent job in telling us the importance of Industry 4.0. And there are all types of initiatives arising from across the world focusing on manufacturing and on factory. China, I think, has a Manufacture 2025 plan. Japan has theirs as well. All of these countries are starting to pursue manufacturing because it is the lowest hanging fruit. And it is the one where you will be able to extract the most value in lowering operations cost. And what IoT does for Industry 4.0 is really, it's a specific application of IoT in the manufacturing setting. It is how you use IoT and the way that the data comes off of it, how you gather the data, how you analyze the data, applied in a manufacturing setting that's going to allow you to move toward this new stage of factory automation. If I go next one. And this one shows a little funny here. I apologize. But there are 3 key fundamental capabilities that IoT provides that's applied in Industry 4.0. And so those are the ones on the left here, I guess, that goes from bottom up. So the very basic piece that IoT allows you to do is it allows you to connect and collect. That's a very easy way of thinking about it because the connectivity awarded to you by IoT allows you to start to stream information off of all of your devices and all of your sensors. That data needs to go somewhere, that needs to be collected, and it needs to be harvested. The way that you would move beyond just data collection is to start to configure and analyze it, and that takes us to step 2. So a complete IoT strategy needs to be able to securely connect, be able to scale and collect all of this massive amounts of data that's coming off of IoT and start to do something with it. Configure it with settings on how you're going to be applying it, whether it's to design, it's to manufacture, to operate, or to service. And then take that even a step beyond to things around analysis. That's still, I would say, more fundamental. Right? As I mentioned before, analytics is only the first step of deciphering the needs of IoT data. The third most important stage is the top one, predict and act. That's where you're going to get the value, is to take your analysis to a stage where you can start to make decisions smarter, and you can make decisions faster and act accordingly. So architecturally, how we see IoT is shown on the next slide. So in order to take advantage of IoT applications, we think that this is how it breaks down in a manufacturing setting. As I mentioned, you have a fundamental layer around connecting and collecting. That needs to be done at a platform level. You need to connect and collect your information and bring it into a platform, a cloud platform, optimally. But there are various stages of maturity. But we think that IoT allows you to start to get value by very fundamentally collecting and connecting. As you move into the configure and analyze and predict and act stages, you'll start to see value. And we see value in 3 major areas around manufacturing: time to market, optimized operations, and efficient asset utilization. Those 3 are the key driving factors around manufacturing, IoT for manufacturing. And the reason that they're broken down this way is that if you look at your cost and your capital expenditures around a manufacturing plant, these 3 are the key phases of your cycle that's going to be able to save money around IoT. time to market is all about rapid prototype. So I think Daniel's said a great thing about how we're able to infuse new information into our products, and we're able to iterate on them, doing them very quickly using technologies like 3D printing and such. Rapid prototyping is going to significantly save the time in which we brainstorm an idea about a product and actually make it come to life. Around optimized operations, this is about looking at your entire manufacturing process and thinking about the various pieces that go into it, right? There's the operations, obviously, the transparency of how a goods move, how the information of the good moves along the manufacturing supply chain. There's workflow automation, people, resources, how we can optimize that based on how we utilize IoT data. Things around resource efficiency. And resources is quite elaborate, right? We're talking about your work resource, your asset resource, your inventory is also a resource. How do we optimize that? How do we make sure that you're not overstocking, that you don't have too many spare parts in your inventory? Looking at service management and looking at energy and space optimization. So if you start to think about your operations in a very cohesive bundle of the various pieces that apply to it, operations using IoT, it becomes much more interesting. And third, I think this is very exciting, is the efficient asset utilization. Especially in a manufacturing setting, people have spent a lot of money in their assets. The robotics, the conveyor belts, the supply chain are all large capital expenditures of operating assets. These assets can deliver you so much more by using IoT. You can squeeze out so much more efficiency by understanding their uptimes and downtimes, by predictively maintaining them, by being able to proactively set your maintenance schedules so that it doesn't interfere with your manufacturing process. So asset utilization becomes extremely interesting, and then that will help you improve manufacturing quality. It helps you with warranty analytics and even remote diagnostics as we apply IoT. So if we move on to the next slide, this is how IBM approaches IoT. So like I mentioned, we started an IoT journey back in 2008 around Smarter Planet. Since 2014, we launched the IBM Internet of Things business unit. And then at the end of last year, we started Watson IoT. And what that means is that we've now decided in a very strategic move that IoT by itself is not enough. We need to incorporate the cognitive capabilities and thinking around Watson, infuse that into analyzing IoT data. And so we've created the IBM Watson IoT platform. Like I mentioned, this is the most fundamental step of IoT, and I'll cover the 4 key capabilities of an IoT platform that we believe are the most important and for it to be cognitive. Above that layer, we are looking at the ways that we can improve the value chain for a company. So from a product development cycle or from an operation cycle, there's the specific packaged and more advanced applications that go on top of that. And on the very top level view is around IoT industry solutions. And we believe that there's so much value from an industry context. So manufacturing is one industry that we're focusing on around Industry 4.0, but there are other types of industries that we've derived a lot of value from. We've had a lot of large clients in things like aviation, like Airbus, or with automotive manufacturers in making newer and cooler connected cars using Watson technology. But the industry lens around IoT becomes even more important, and it becomes very important to our clients the unique set of data and information that brings along with the whole IoT context. And so those are things that we're building out with our clients currently. So I'm going to deep dive a little bit into platform. So if we move on to the next slide. The IBM Watson IoT platform was specifically created for IoT because as we were looking at the platforms that are out there, we thought that a lot of them miss key components that we thought were integral to IoT. And so, can you go back? Keep going. Thank you. So if you see on the top here, we have connect, information management, analytics, and risk management. Those, we believe, are the top key capabilities that's necessary in an IoT platform. Connect is easy to understand, right? To be able to securely connect, to be able to device manage, to be able to see the connectivity around your IoT devices. Information management gets a little bit more complicated, and this is what I mentioned before. IoT is not just about connecting your own devices and seeing the data coming off of it. It is about how you combine your data with other types of data sources to derive more value. So we strategically acquired the weather company last year, and that gives us so much more opportunity to do things with IoT. Considering if you have a factory, right, where your factory is makes a very big is a very big factor to how your factory operates. A factory that's operating in Siberia is not going to be the same as a factory operating in Ecuador, right? The temperature differences, the atmospheric differences are all going to have effects on your machinery, on your large-scale capital expenditure assets. So being able to combine other types of data sources into how you're managing your assets becomes very important. I've already mentioned analytics, and we've taken that from contextual analytics to real-time analytics to predictive and now to cognitive. We think that cognitive capabilities around analytics are going to be the key to the future just because the amount of information that's coming off of IoT is so massive that you will not be able to conventionally process it the way that you do. And then, of course, risk. So we've heard a lot about, security and privacy and risk management. We're taking risk management to a different level. Not only is it about secure connectivity of your devices, but you need to look at risk from a landscape perspective of all the devices that you have out in the field. Which ones are going to be giving you trouble, the ones that you think are going to be flagged as security risks. That's what risk management is all about. And so to invest in these 4 capabilities, if we move one more slide, we've taken strategic steps to actually build out additional capabilities into each of these. So specifically around risk management and connect, we have done a lot of exciting work around blockchain, which is the new type of distributed ledger security protocol that was invented by the finance industry, actually. Blockchain is going to award us a lot of great work around secure connectivity, secure information exchange. And so we've infused that into our connect capability and our risk management capability. Blockchain right now at IBM and with our clients is currently in beta, and we will be shipping our platform with blockchain capabilities very, very soon. The next one is around weather company. So as I mentioned earlier, we strategically acquired the weather company because we believe in adding other types of information into our platform and be able to combine that information with others. What's also really exciting about the weather company was that they have built out an IoT platform of their own. And the learnings that we've done to merge the weather company's platform into our platform allowed us this extra capability around opening our platform so that it is composable and it is easily connectable and to become a platform of platforms kind of idea. And which is extremely strategic if you think about the amount of IoT platforms that currently exist. Right now there's over 250 IoT platforms currently. That number is going to reduce significantly as standards start to converge and then as we start to see a consolidation. So being able to have a platform that's open, that's easily accessible, and that's composable in the pieces that I've mentioned below is what we think is going to be the future of an IoT platform. If we move forward again, around analytics. So as I mentioned, we were already starting to take in the cognitive capabilities of Watson into our IoT platform. So the 4 cognitive capabilities that currently exist right now around natural language processing, which includes Chinese, machine learning, textual analytics, which means that all of your reference data and information can go into the platform and is easily searchable and combinable with your own data, and and we also have video and image analytics around 4K image detection and things like that around our platform. So all very exciting things around cognitive, and there's so much more to be added around Watson and cognitive. So if we move forward again, now we start to shift up a layer, right? So now that we've covered the 4 key fundamental capabilities of a platform, we're really looking to infuse cognitive insight into the product development process. So being able to accelerate time to market of these connected products by being able to analyze the requirements of your new products, how they're prototyped, how they're being used out in the field, generate data back, infuse that back into your next iteration of products, and being able to do that as efficiently and as quickly as possible. If we move forward again, around critical assets and operations, and that I mentioned is the other side of the stack, is around taking a look at all of your assets. So from your work, your service, your contract, real estate, supply chain assets. It's all about taking a comprehensive look at your operations and seeing where the efficiencies lie, seeing how we can automate the processes of workflow and manufacturing and service. We specifically helped out a large client of ours by just taking a look at their spare parts inventory. What we realized was that they had been over-maintaining their assets because the repercussions of it being down was so high. So they would stock probably 90% extra spare parts that was necessary. And so in order to make sure that they were always up and running. And by being able to take a look at the analytics behind it of what is the most optimal operating, when is the best time to service, when is the best time to actually utilize your spare parts, we're actually able to reduce their spare parts inventory by 90%. So it is a very significant cost to them and a very big savings to them now. And as we move forward again, we'll move into the predictive maintenance. So as I mentioned before, asset becomes more and more important with manufacturing just because of the very large capital expenditure of the things that you have. So being able to predictively manage your assets, being able to take a look at the analytics, the algorithms, the information around your uptime, your downtime, combine that with other sources of information, including things like I mentioned, weather outcomes at an oil rig, to combine that, and even with the expertise level of your own engineers. So if your machine was maintained by a junior engineer, it may not have the same time of duration of that it would with a professional or a longer senior engineer. So that's why all these things come together as different sources of information come to play around IoT and predictive maintenance. Next one. So as I mentioned already, we've been extremely passionate about pursuing industry-specific solutions. And this is a very interesting area because we've co-developed a lot of these with our clients and our partners. Because we believe that IoT is not a one-person game. So IBM does not claim to be the expert in every industry. We need our partners to do that. We're actually heavily partnered with Bosch, for example, around product development and around automation and industrial products. So this is all a joint effort in order to create the new pieces of IoT and Industry 4.0 that needs to come to play. So if we move forward again, you'll see that we have been a leader in IoT by participating in open standards and industry initiatives. Like I mentioned already, IoT is so new, so exciting that there are so many standards bodies out there. And our strategic direction is that we don't believe it is a one-size-fits-all, right? There's a lot of standards out there. We need to be able to help the industry gather them together and move them toward the right direction. If we move forward again, like I mentioned before also, is we believe IoT is really about an ecosystem. An ecosystem means that you need collaboration and you need partnerships to make it happen. So IoT, for us, where we pursue more around platforms and analytics and cognitive insight, we've heavily partnered with device and gateway sensor manufacturers to make sure that we have end-to-end connectivity and security of IoT from the device all the way up. So partnerships with ARM, Texas Instruments, Intel. It's an extremely open ecosystem. So this is actually a a picture of our developer works website, so where we have a lot of our partners contribute how they would connect to their devices, the security protocols around that, and we've been able to gather the value together on how we put IoT together in an end-to-end state. And so I'll conclude with the very last slide. I want to mention that something that I said in the beginning, which is IoT is not very difficult to get started with. And it is not a far-fetched thought to think that the companies, the manufacturing plants right now that are in Industry 2.0 can actually advance to Industry 4.0 very quickly. And that's because IoT has a very easy on-ramp. So even if you go to ibm.com/IoT, you'll see that you can actually hook up any of your sensors, like a Texas Instrument sensor tag, to your mobile phone and start to see data coming off of the cloud immediately. And you're able to play with some very basic fundamental analytics around it. And you're able to see value from it very, very quickly. So I think the point of the story is a lot of people are really afraid of the investments of IoT, on how to get started, on whether or not it will give you value. And the truth is, the ease of use of IoT and being able to get started is extremely simple because of the capabilities of cloud, because that you don't need large-scale investments. They can be by microtransactions. You can start to hook up sets of your sensors at one time instead of your entire factory. And that's what makes IoT powerful, and that's what makes IoT here. So, thank you very much.
好，谢谢。好，谢谢佳妮的精彩这个分享。IBM 做了大量的这个研究，这个佳妮呢，对 IBM 的一些研究深入的一些见解都跟我们进行了分享。那这个在我们这个大会组织者 set up 这个我们的讨论这个过程当中呢，我们也给大家一个机会啊，这个大家看一看刚才的 session 有哪些这个大家想问的问题。好，这边的 David， 哎，这好。
Okay, thank you, Jiani, for your great
Well, thank you.
better understand what is IoT.
Okay.
Actually, we all know this is the future trend. We go to Industry 4.0. My question is, what is the key barrier for, especially for China manufacturers to switch to, IoT or Industry 4.0? Like Yongchun mentioned, a lot of China manufacturing may be still manual instead of automation, maybe just 2.0. So, what is key barrier for that?
Well,
主要的障碍是什么？这个 move 到这个
Her question is about barriers of moving to Industry 4.0.
obviously different considerations for different geographies. So, for example, for Western developed countries, it's more about lowering operations costs, which I think is true for China too. But I think the largest key value for IoT is actually manufacturing quality. The amount of manual processes that goes into inspection, that goes into waste and yield inefficiencies is very high. So if we're able to reduce that by taking a look at the sensor data, at the analytics around what's actually optimal, that's what's going to be the key value here. So like I mentioned, it varies from company to company because each manufacturing company is looking at very different things, right? But the key...
Yeah.
No microphone.
Oh, barrier. I think that cloud is very well used consumer-wise, but I don't think cloud is that easily approachable yet in China from an industry point of view. I think there are a lot of cloud providers in China already, but not ones that can actually take you to the next level based off of what you need in a platform, like the analytics, like the secure connectivity. The cloud adoption, I think, is a big barrier here. I think the other part of it is investment. I think a lot of Chinese companies that I've talked to around Industry 4.0, they still tell me, I'm not sure if I can actually see value. I'm not sure if I want to give in to the investments around it, because I think IoT is going to cost me a lot of money, and I don't know what the marginal benefit would be. But actually, so that's why I mentioned it again and again. IoT is not a big monster. It's actually extremely approachable and extremely pilotable, that Daniel had mentioned. So being able to take that to the next generation, I think it needs foresight and it needs an IoT strategy.
Any example, or you have for some customer, what is the ROI for this kind of project? Means return on investment.
Yeah, ROI. Well, it depends, obviously. Like I said, it depends on the type of application of IoT. For Chinese customers, we have already started a couple of key projects with aviation industry. And that's obviously a big security concern. The yield factor, the quality concern of aviation is very high. So that's why they're able to work with us on that. But it's a little too early to tell. From our use cases with developed countries, with big companies like Whirlpool, with Kone, with Siemens, then their return is extremely high. Like energy savings with Siemens was more than 30%, which if you think about a facility running lights, how much money is that going to be costing you? So, like I said, it varies from client to client.
Thank you.
好，谢谢。看来思想这个观念的转变是最大的障碍啊。咱们眼见为实，希望更多的看到这样的实例 benefit。
No, we'd very much like to hear more like case studies, right? That.
Stanley, I work for Penske Logistics. Penske here. You talked about like a lot of good things about IoT, and such as like spontaneously getting feedback for customer experience here, and then you can help build a product and even shorten the product cycle here. Did you think that that even the sales model would shift to like the e-commerce more? Even for example, for the traditional sales channel, like manufacturer, distributor to physical store, that even market that we shrink in the next 5 years. What was your comment? I would like to know.
Can you elaborate on your question a little bit more? What do you mean by shrink?
My shrink is with the spontaneous getting the feedback, the customer experience here, that you would be able to manage and even design your product here. That kind of inspired for these manufacturers to go to e-commerce, because with the time you're getting, the feedback you from the customers, so you might focus on more in the e-commerce instead of for the traditional sales channel.
Traditional sales channel.
Yes, exactly.
Right. Yes and no. I think you're right. So as we mentioned, because a lot of companies will need to take the transition to move to an e-commerce model, the engagement that you're going to get with your consumers are going to be tighter and tighter. But IoT also builds pretty complex devices. So from a consumer level, I think that's very true in terms of moving to an e-commerce model. But for an enterprise level, I think service is going to become even more important. And service and direct sales channel is going to become very important, because it's about understanding the value of a specific product. Because products are going to be more complex, there's going to be an on-ramp on how you help your customers understand value. So even in our mentality, as we're working with our clients, we've first moved them from customers to clients, because it's a collaboration, and actually from clients to partnerships. What that means is it's not about me selling you an end product and that's it, right? You're going to put that into use. You're going to start to see information and data off of that real time. So then it's about how we can couple with you in order to understand more information together. So it's going to be a very interesting information economy out there. So there's no longer a direct sales relationship anymore. I think there's going to be actually a lot more collaboration. And so the individual relationship from a sales model perspective is going to be more important. I think there's one right here.
最后一个问题，我们就进入到这个小组讨论啊。
Okay, last question.
My name is Jiani Zhang. I'm responsible for Cargill Asia supply chain. So I have a question about, that in the cognitive learning, which I think is a very good word, your cognitive learning about the analytics.
Yeah.
And we have heard about machine learning very much. And how do you think about some of the supply chain jobs, such as planning, coordination, logistics, can be, and when how be replaced by the machine learning? Is this going to be a near future? And in that situation, what kind of what will be the solution for the people, supply chain talents to see in the future? Is this going to be a more individual contributor as SME to working with these companies, or there could be a kind of a pyramid model in the future?
Yeah, that's actually a really great question. Logistics is going to be a very big value driver for factory and for Industry 4.0, for IoT actually. So like you mentioned, machine learning will kick in. It'll start to be able to analyze the most optimal routes. It's going to be able to, refine on the value of how your shipping logistics happen. We actually work with a port in South America, Port of Cartagena, specifically on how they direct and route the containers that come into their shipping port and the logistics pieces off of that. So I think it is in the near future. In fact, they've already instrumented their entire port to do logistics in that fashion. So it's going to be upcoming and widely adoptable by a lot of companies. From a resource standpoint, I think it's going to move toward more of a specialization. It's not that you don't need your expertise anymore. It's more about how they apply that expertise, right? Machines are not going to take care of everything. Even machine learning is based off of cognitive experience. So your experts are going to be feeding that cognitive experience, and it's going to be able to refine on that to better make predictions and outcomes. Right.
Thank you very much.
好，谢谢佳妮的回答。那我们再次感谢佳妮的。
Okay, thank you very much, Jiani, for your wonderful presentation.